Hello guys, we will discuss binary search in this video. In the previous video, we talked about the linear search. If we want to search any element in an array or vector, then we can go through each and every element and check whether uh, that element is equals to our searched element or not. So the time complexity in linear search was order of n. But now today we will discuss about the binary search. So before applying the binary search, we should know that the vector or a element should be element should be ordered, that is it should be monotonically increasing or decreasing. You can see that the elements are increasing toward the right, so then only we can apply the binary search. In this case, if we apply the linear search, then if let's say if we want to search the element 63, then in the linear search, how many comparison will be needed? First of all, we will check this, then we will go to 16, then 23, then 32, then 46, and then at last we will find the 63. So six comparison are needed in the linear search to find the 63. But if the array is already sorted or monotonically increasing, then we do not need to go each and every element. What we can do? So instead of going in a linear fashion, what we can do is we can have two pointer, that is L, that is will point to the zeroth index, and one is R, that is right, left or right. R will be point to the end of the array. So we can find out the mid index of this. So if L is 0 and R is 8, what would be the mid index? Mid will be L plus R upon 2. So it will be 0 plus 8 upon 2, that is 4. So we will check whether element at fourth element at fourth index is matched to our element. Our requirement element was our element was 63. So we will compare the 63 with 46. Whether if ARR of mid is equals to element. If we found the element at the mid position, then we will simply return that element is found. Okay. Otherwise, what can be the case? If mid element is not match with our requirement element, then this element will be lie either to the left of the mid element, right of the mid element, or to the left of the mid element. So our array will be divided into the two halves because it is in a this array is monotonically increasing. So we will compare whether 63 is greater than 46 or not. If it is greater than 46, then we know that the elements which are left to the 46 are smaller than 46. If our required element is greater than 46, then we need to search only to the right of the mid element. So our L will be shift to the right of the mid element. That is, now our L will be point to the fifth index. Now we need to search to this array only, to this range only. Then we will find out the mid element. Now again we will find the mid element. L over L is 5 and R is 8, and now we will get 8 and 5 is 13 and 13 by 2 is 6. Okay. Mm. Then we will found then we will find that this is a mid element. We will check whether 65 is equals to 63. No, 65 is not equal to the 63, but 63 is smaller than the mid element. So we know that if 63 is smaller than 65, then 63 will lie left to the 65. So we will search to now we will search to uh, this portion of array only. So now our R will be shifted to this location. Now again we will check our mid is now L is 5 and R is also 5, and we divide it by 2, then we will find that mid is 5. Now we will check whether the element is present at mid position. So we will check here 63 is matched with 63, then we will simply match this condition will be true and element will be found. There are three cases. We can find the element at mid position, or else if ARR mid is greater than element, that is if element is smaller than element at mid position, then we need to search in left of the mid, then we will decrease the R to mid minus 1. Okay, else we have checked the equal condition, we have checked that element is smaller than mid position. Else condition will be if element is greater than mid position. If element is greater than mid position, then we have to check the element to the right of the mid element. So we will increase the L to mid plus 1. I hope you understood the algorithm. This is a very simple algorithm. If you have understood, then you can skip the part and can go to the coding part. Otherwise, let me repeat again. So initially, our array is given. So before applying binary search, we need to check whether our array is monotonically increasing or decreasing. So if we check that this array is already sorted, so we can apply the binary search. Now we have the two pointer that is at the beginning of the array and one is at the end of the array. Then we will find the mid index and we will check if our element is equals to the element at pointing to the mid index, then we will simply found our element and we will return. Otherwise, there can be the two case. Our element can be greater than the mid element, or our element can be smaller than mid element. If our element is greater than mid element, then it is for sure that our element will be lie. If it is present in the array, then it will be lie right right to the mid element. If it is smaller than mid element, then it will lie on the left of the mid element. And accordingly we will shift our pointers. If we have to check left of the mid element, then we will uh, decrement the R2, or we will set the R to mid minus 1, and uh, we will do not change the L, it will be remain same. And if we want to search the 63 to the right of the mid element, then we will increment L to uh, right to the mid position. And now our range of search will be this. So L will be here and R will be here. And now again we will find the mid element, and this process will go on until uh, until L is smaller than or equals to R. Okay, so this will goes on. Now let's discuss the code. So let me take an array vector which let me put the random values here. Okay, now we will create a binary search function, and we will pass the array and element to be searched. Let's say we want to search the 82. Now let's create the function binary search and argument as vector of int and element to be searched. Now we will set I is equals to 0 and or L is equals to 0, that's a left pointer, and R is equals to array of size minus 1. Okay, and while L is smaller than equals to R, then we will keep on searching and we will find the mid element, that is L plus R upon 2, and we will check if at the mid position we found the element, then we will see then what will we do, we will simply see out that element is found at position mid, or we our element can be greater than AR or mid, then we need to search to the right of the mid position. R will be mid plus 1. Other case can be element will be smaller than AR mid element, then our okay when element will be greater than mid position, then our L will be shifted to mid plus 1, and when element will be smaller, then R will be shifted to mid minus 1. Okay, and if we will found the element, then we will return from this function, and at last if we do not found the array, if we do not found the element, then we will come to here and we will print that element is not found. Okay, now let's run this. We will see say 82 is found at position 7. Now let me give another value. Let's say we want to search 23. So 23 is present at position 1, 0 and 1. And let me give element that is not present in the array. Let's give 100. So our element is not present. So we see that 100 is not found. Okay. So this is a very simple algorithm. You will run. You can run it by your own. If you do not understand the concept, then you can rewatch the video, and yeah, you will understand. You will understand it better. Okay.